a state that nearly 14 billion years ago expansion started. Wait, began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall, we built the pyramids. Math, science, history, unraveling the mystery, and it all started with the Big Bang.
Good morning. How are we doing? Welcome to another super engaging, super exciting, quick daily check-in, or weekly check-in, I guess, at this point. Anyways, today we're going to briefly talk about the Big Bang and kind of the evidence that scientists have used over the past 10, 20, 30 years to kind of make the Big Bang Theory the most accepted theory when it comes to the creation or formation of our universe. So I made a PowerPoint to go along with today's video lesson. So the past 2 days, or 3 days really, on Friday you started with the Big Bang. So you should have read about the Big Bang a little bit, watched a few videos, and then yesterday's activity you were investigating the Doppler effect and this idea of redshift of galaxies. So the Big Bang, what is it? It's a theory that describes how the universe first formed. So really, it's the beginning of time. Before the Big Bang, time did not exist. After the Big Bang, time began. So looking at a few slides. So time begins. So the Big Bang is basically understood as this singular event. So the universe is infinite, right? It's not a finite object. It is infinite. That being said, it was something before the Big Bang. We like to use the analogy of like a marker top, which would be this, and then within a really small amount of time, the point of this marker grew to the size of a large house. You could also use the analogy that an atom went from the size of an atom, which is microscopic, to the size of a grapefruit in less than a second. So that time is 10 to the negative 43rd power. So 1 second to the negative 43rd. If you were to do this on paper, it comes out to be an incredibly small number. So there's actually 41 zeros behind the 10 when you put it into standard notation. So in less than a tiny fraction of a second, the universe began. A lot of times you think of the Big Bang as an explosion. It was not an explosion. There was something, this singular event, that imploded or stretched. So sometimes you might read things or watch movies, listen to things where they may describe the Big Bang as more of a big stretch. So it'd be like taking a balloon, which is already a thing, and then blowing into it, which would expand the balloon. That's the best way to describe the Big Bang event, is that it was an implosion or a stretching of matter into a larger universe. So then, quickly after that, less than a second after this singular event to create the universe, scientists describe it as a hot soup of electrons, quarks, and other particles. So on my slideshow, my video's in the way, but here's your soup of electrons and quarks and other tiny microscopic particles. And then still less than a second, we have the rapid cooling of the universe, which allows those quarks to clump into protons and neutrons. So we start to get the first forms of matter. However, no elements are formed yet, just starting to get clumps of protons and neutrons. And then finally, we reach 1 second. So imagine 1 second, right? One. Or if we pull our phones out, we have go to my clock, and we go to the timer and our stopwatch. So if I put my stopwatch up and hit start, anyways, that's about 1 second. So after that 1 second, we then have the universe. It's still too hot to form any kind of matter or elements. So it's just a super hot universe of fog, or as you young kids say, lit fog.